guys, welcome to my YouTube channel. Today guys, I'm going to show you how we're going to prepare this wonderful fridge. So what we have here is the latest versions of refrigerators, the one which does not have an inbuilt evaporator inside the wall. So what is happening here, the client is complaining that this side, which is the refrigerator, is not cooling and it's very warm, but this one is cooling, but after a certain while the ice start to melt. So when I came here, if you can see right here, okay, like this is how the cover looks like. So here the fridge sucks warm air through here, and then the fan which is behind this then will force cold air. Okay, this one is sucked by the fan here, air is sucked, warm air is sucked through here and through the evaporator, then it is forced into the refrigerator warm, so colder. So these are the holes or the pores to which cold air is released to the fridge. And same, if you open this cover right here and remove the fan right there, it's still connected. Okay, so you can see what I am saying right here is where we suck our warm air through. Then we have a fan right here, which is the one which is sucking and through the evaporator, and that's our evaporator right there. You can see that it's frosted, and we're using R134A for this system, so it's completely frosted. Then, so what I'm going to do right now, I'm going to test the defrost, which is this one, the element, and also to test you can see that we have enough refrigerant inside the system, and also we have this one. If you see that hole, it's the hole through which cold air is sucked, is forced up there into the refrigerator compartment, since this one is the freezer. Okay, like this. So right here is the information for the refrigerator, the wiring circuit, the type of refrigerant, and also the size or the capacity of the fridge. So here we're going to remove the panel and see if the diaphragm, which allows cold air from the freezer to be emitted or to be forced up here into the system. So this one is the one which acts as a temperature regulator. When a set temperature right here is reached, that system over there is the one which cuts the flow of cold air through here. So it's the one which regulates the temperature. Okay guys, so since I'm doing everything on my own, I'm going to just pause to just remove the cover so I can show you at the back. Okay guys, so right there I've managed to remove it like this. So if you can see right here, this one should be for temperature sensor, and this one is for the motor. So the motor is controlling the diaphragm which is inside. So what I think, the motor might be broken, but it was broken when it was closed. It was stuck closed. So right now I'm going to remove it and show you further. I'm going to remove the connectors there. Okay guys, so what is happening here, you can see right there, this one, we have the wire for the motor which is inside there. So there is the diaphragm, so air is blown, cold air is blown through there, and this one is the one which regulates the temperature. When it reaches the temperature, it closes. The motor will close the diaphragm, or when the temperature is not reached, this one will remain open. Okay, yeah, I lost control then. Yeah, now if you can listen, you can hear the motor. Yes. You can see the diaphragm there. Close it, open it. You can hear the motor. So now it was stuck closed like this. So no cold air was allowed to come into the refrigerator compartment. So that's why it was warm. And right now we're going to check if the elements for the defrost are working, because the freezer compartment is not working perfectly well. Okay, so that's it, guys. So what you have to do is to make sure that the motor is working. So I'm going to test the motor. I'm going to show you how to test it. Okay, guys, so right now I'm going to open here to remove the diaphragm. Just pull it out like this. Okay, so now this is the DAPA. Okay, so right now I'm going to test and see and find out what is going on here. Oh guys, there's important information right here. We can see that the motor for the damper, it uses 12 volts DC and 60 milliamps. So right now I'm going to grab a charger, a 12 volt charger, and see if anything is going to happen here. So it's DC 12 volts. So I've opened the motor, and this is how it looks inside. So we have the motor and a couple of gears, so that just by a few turns we can have, from multiple turns of the motor, we can have a minimum of 10, so that we can control it precisely. Look how many turns do we have here, and look at the motor. The motor is turning 1,000 times only to get a 110 here. You can see the motor there. Okay guys, so this one is a 12 volt charger, and I am going to test if the motor will turn. Alright, so we have 4 terminals right here. So we're going to start. Pause it. So right now we're going to put the first 3 terminals like this, and we don't have a turn. Then the second one, then the and third. Yeah, I hit a vibration. Okay. So I am pretty sure that the motor is not working. So what we're going to need is to replace the motor. Yeah,